What is green theorem? Green theorem gives a relationship between the line integral of a two-dimensional vector field over a closed path in the plane and the double integral over the region it encloses. The fact that the integral of a two-dimensional convergent field over a closed path is zero is a special case of green theorem. This is a diagram that shows what green theorem looks like. F is a two-dimensional vector field. R is some region in the xy plane. And C is the boundary of that region oriented counterclockwise. Now, let's move to simple question of green theorem. So the question is, calculate C curve negative x squared y dx plus xy squared dy, where C is the circle of radius 2 center on the origin. To solve this question, green theorem have tell us that if f equal to m and n, we will let m equal to negative x squared y and n equal to xy squared. The equation will be like this, that C curve negative x squared y dx plus xy squared dy equal to double integral y squared minus negative x squared dA. So double integral x squared plus y squared dA. Our dA is represent to polar coordinate. So we sub x into r cos theta and y into r sin theta. This we will get r squared cos squared theta plus r squared sin squared theta. Then we will get r squared r dr d theta. After do the first integral, we will get 8 over 3 d theta. And then we do the second integral and we will get 16 pi over 3. This result is 4 over 3 times the area double integral 1 dA of the circle, and so it is a plausible answer. Thank you.
Question. Ralph Rangnick, the Manchester United football manager, want to redesign the Old Trafford Stadium. So the stadium is ellipse in shape. He also want to install spotlight in circular shape. He also planned to install 4 VAR cameras to observe players more clearly. The equation of ellipse, x squared per 5 plus y squared per 10 equals to 10. Meanwhile, spotlight, x squared plus y squared equals to 40. The equation is A. Find the area coverage of the new stadium. B. The area of spotlight fitted around the stadium. C. Evaluate integral of y cubed dx minus x cubed dy for the boundary of region which the light will be placed. And D. Integrate the xy squared dx minus x squared dy where the VAR camera vertices in 2, 2, 2, negative 2, negative 2, 2, and negative 2, negative 2. So this is our visualization of the new stadium. 4 VAR camera in the center, circular spotlights, and ellipse stadium. So for the first question A, given x to the power of squared over 5 plus y squared per 10 equals to 10. From the equation, x squared per a squared plus y squared per b squared equal to c. So we will know that the value of a is set 5 and the value of b is set 10. So just substitute in the a and b, and for the x and y, we will find the dx and dy. So substitute also the dx and dy to get the final answer of 7.07 pi. For the question B, given that x squared plus y squared equals to 40, the formula of the circular spotlight. So as we know that the A is 1 and B is equals to 1 also. So the area is per 2 integrate x dy minus y dx. So we know that x equals to A cos theta. We will find the dx and y also the dy. So we substitute into the formula to find the area and then to get the final answer of 1 over 2 multiply with 2 pi to get pi. For the equation C, integrate y cubed dx minus x cubed dy. P equals to y cubed, q equals to negative x cubed. We will need to find the delta q per delta x and delta p per delta y. So after that, we will replace the dA with dr d theta, and x and y we will replace with 1 or r cubed. The final answer after multiply with 192, we will get the value of negative 3.84 times 10 to the power 6 pi. And for the final question, for VAR's camera vertices, we will need to find the integral of xy squared dx and x to the power 5 dy. Find the delta p per delta y and delta q per delta x also, until we get the final question of 64y in bracket 2 negative 2. Substitute the 2 and negative 2 will get 256.
Example question 2. In electrostatic, the electric field line can form any closed loop. However, the electric field line in electrodynamics form closed loop, which is entirely based on the Grimm theorems, such as relation between integral and differential from of Maxwell's equation and the energy of steady current. Solve the following line integral using a Grimm theorems based on the above condition. For condition 1, integral 1 plus x y square dx minus x square y dy, where C consists of the arcs of the parabola y equal to x square from negative 1 1 to 1 1. So we go to the example solution for question 1. So firstly we write the general equation of the Grimm theorem. After that we compare the general equation and the solution and the question given. So we get the value of m and n. We get the value of m equal to 1 plus xy square, and value for n is negative x square y. So after that we integrate m respect to y, so we get the value of m equal to 2xy. After that we also differentiate m respect to x, so we get negative 2xy. After that we put all the value and differentiate m and n into the general equation. So we get, after we calculate, we get the double integral is equal to negative 4xy dx dy. And at this they are given that C is consist of the arc of parabola equal to y equal to y x square. So we write the equation y equal to x square and we differentiate. So we get dy equal to 2x dx. After that we put all the value into the equation. We substitute the dy and y. So after we calculate we get the value negative 8 x power of 4 dx. Okay, after that we put the negative 8 outside and we inside the limit of x equal inside the limit of x, that means negative 1 to 1. That's a given, the limit of x 1 to 1. So we integrate x power of 4, we get x power of 5 divided by 5, and we multiply by negative 8. So after that, we put the value of limit. So lastly, we get the answer is 0.
Question number 2, we need to find integrate x squared y dx minus xy squared dy, where c is the circle x squared plus y squared equal to 4. So we need to compare the equation with the theorem, which is x squared y dx minus xy squared dy. M equal to x squared y and equal to negative xy squared. We need to differentiate delta m over delta y. We will get x power of 2 differentiate delta n over delta x, we will get negative x power of 2. So we need to substitute the value in equation. Integrate delta n over delta x minus delta m over delta y dx dy. So substitute delta n over delta s is negative y squared minus x squared dy dx. So we'll negative outside, integrate x squared plus y squared equal dx dy. So negative integrate x squared plus y squared is 4 dy dx dy. We take the 4 to the outside, so negative 4 differentiate dx dy. So dx dy is area of circle. So negative 4 times pi r squared. R, the value of r is 2. So we substitute negative 4 times pi 2 power of 2. We will get negative 16 pi